Hey everyone, welcome back. So today we will be talking about yet another cool feature of Spark 4.0. The feature we are going to discuss today is about CTEs, and to be precise is about recursive CTEs. So with the earlier version of Spark, it wasn't possible to invoke a recursive CTE into our code, but with Spark 4.0 and Databricks runtimes of 17 plus, it is made possible. And so we will take a look into some business cases on how we can solve multiple hierarchy levels complex cases using recursive CTE, and we are going to see live in the Databricks code how Spark handles the recursive CTEs. But for now, let's check the normal syntax of a recursive CTE. So this is a very classic example of a recursive CTE, maybe in MySQL or other SQL databases. We might have seen this one, and we are going to discuss it live in the code as well. And basically what I wanted to show you was this one, how the recursive CTEs work. So it has a base subquery. This runs once, and it is like a base we set up for our recursive CTE. So this condition is very important, and it is non-recursive in nature. So this condition is non-recursive, and our recursive CTE is built on top of this one. Then we come into the most important step, that is recursive subquery. So this one, we need to take care that we have a termination condition, otherwise it runs infinitely. So this one becomes very important. The important thing being, we should have a termination check in our recursive part, otherwise it is an infinite loop, it calls on itself, and we will receive an out of memory error. So with this in mind, let's jump into our Databricks. Welcome back. So we are into our Databricks environment, and if I can quickly show you the compute, so it is 17.0 ml, and here we see Spark 4.0.0 enabled. So this is 17.0 is compatible with the Spark 4.0. Okay, now let's jump into the code. So this is the very classic example of a subquery. So this is the base part. Select one as n. Maybe if I copy this one and if I can show you, so it will just return one. So 1 as n is being returned. It just returns a constant. This part becomes our base part, and it is non-recursive. So what we are doing is, the base part is always union or union all with the recursive part. And here what we are doing is select n plus 1 from recursivity. So this is our definition of recursivity. We are calling itself in the function itself, and then we have a termination check condition where n is less than 5. So what it does is, so n was 1 for the first execution, then n becomes 2 for this union all part. Then the code runs back and the recursivity is called. Now n becomes 3, 4, and 5. So up to 5 we see, but if we check here, the condition is n less than 5. So when n becomes 5, this uh, block terminates since n should be less than 5, and we see uh, the count from 1 to 5. So let's hit execute and see the output of this query. So this is what we have as an output of the query. And many a times in the SQL interviews, the interviewer might ask to develop a query without using any inbuilt function to that displays the count up to 5. So this is the go-to way in those cases. Now let's check a very practical example or maybe a business case. So we have here is the employees table, and let me show you what values it have. So this is what the employees exist. So the very first record, the designation is CEO. Ravi Sharma is the employee name. So this is the very first in the hierarchy. Everybody reports to Ravi Sharma. So if we check, the employee ID is 1. So now if we go to the second record, the employee ID is 2, but the manager ID is 1, meaning this guy reports to Ravi Sharma. So Neha Gupta reports to Ravi Sharma. And then Amit Verma, employee ID being 3, but manager ID being 1, reports to Ravi Sharma as well. So these two report to Ravi Sharma. Then we come to Priya Singh. Priya Singh employee ID being 4 and manager ID of 2 reports to Neha Gupta. So this is classic example when to use recursive CTE. We have basically different hierarchies. So Ravi Sharma being the manager of Neha Gupta and Amit Verma, and then Neha Gupta being the manager of Priya Singh. So if the business case says that we want to know all the hierarchy of Priya Singh up and down, so a recursive CT is the usual go-to solution. So let's see the query which we have developed. So what we have is recursive hierarchy as, and then this is our non-recursive or base query or anchor query. What it does is it select all the things, and this is the constant one as level. And what we are checking here is the manager ID being null. So this is the top level employee who does not report to any manager, so the manager ID is null. And if we go back to the data, it is Ravi Sharma, the CEO of the firm. So this part returns Ravi Sharma. And then what we sort of do is we have a base case now. We can either use union or union all. That is required for a recursive part. And then we develop a query where we sort of uh, have some logic in this other part where we define a level as required. And then what we do is we inner join it with hierarchy. So if you know, the inner join will terminate when there are no matching conditions from the hierarchy part. Currently hierarchy part only has Ravi Sharma, but we know that so here you see we are inner joining the employees with the hierarchy table, and we are doing the inner join on employee dot manager id equals hierarchy dot employee id. So this join acts as a termination condition. The inner join will terminate whenever h dot employee id is null, or maybe whenever e dot manager id is null. So in either case, the inner join will return a finite number of outputs and also serves as an termination condition in our case. And once the inner join terminates, the recursive city will be complete. So what we are doing is we are joining a table with the recursive query itself. Many a times you will see the same. So now what we do is we have employee dot manager id should be hierarchy dot employee id. This means that for the first two records, Ravi Sharma's employee id will be the manager id of the employees. I believe the two employees were Neha Gupta and Amit Verma. So this is the use case, and then it will sort of keep on increasing the level, and then going downwards towards the hierarchy. So let hit execute and see what we have as the output. So now what we have is the level. This is what we wanted as the hierarchy of the employees. So if we see, Ravi Sharma has the level 1, reports to no one. And then these two employees, Neha and Amit, they report to Ravi Sharma, and they are on the level 2. Then these two report to the hierarchy of 2, so these are on the third level, this one being also on the third level. And then the next three employees are on level 4, and this last employee is on the level 5. So this is the intern. If we sort of go upwards towards the designation, the level decreases, or vice versa. If we go towards the downwards, the level increases. Another way to visualize this is the sales intern has 5 level up of hierarchy, or the CEO goes down to level 5 of hierarchy. This is the classic example of a recursive city. So whenever we find a business case where there are multiple levels of hierarchy and we want to sort of assign a level to those, we will go for a recursive CTE. That's the most common use case. So with Spark 4.0, we have many cool features, this being one of them. So I will be covering all of those in the coming videos. So please stay tuned, share this channel among fellow data and AI enthusiasts. See you in the next one. Thank you.